Hello out there, welcome to my channel. My name is Olutola. Thank you for joining me once again. In this practice question tutorial, I'll be working on the inverse of a 3 by 3 square matrix. The matrix is given as A equals to 2, 3, 5, 4, 1, 6 and 1, 4, 0. So the first thing I'm going to do here is to find the determinant of matrix A. The determinant is always given in this form. We write it in this form. So it should be equals to, first I need to put my sign. This will go with, this column will go with plus, this will go with minus, this will go with plus. So that's more of my sign convention. Plus 2 into bracket. I'm using a bracket now, so I'll pick the cofactors now, and that will be 1, 6, 4, 0, 1, 6, 4, 0. Then I take the next one, which is negative 3. So negative 3. Then I have negative 3 on that row. I close up the row, close up this first row, and I close up the second column. So that will be 4, 6, 1, 0. So then I go again. That will be plus 5, plus 5. Then I close up the row. That means I'm not taking anything here. That will be 4, 1, 1, 4. We have 2 plus 2 is still 2. So 2 into bracket is 0 minus 24. So that is 1 times 0. That's 0. Then minus 6 times 4, which is 24. So I close my bracket, minus 3 into bracket 4 times 0 will give us 0 minus 1 times 6, which is 6. So plus 5 into bracket 4 times 4 will give us 16. 16 minus 1 times 1 give us 1. So that will give us 2 into bracket negative 24 minus 3 into bracket negative 6 plus 5 into bracket 15. So this will give us negative 48. That's 2 times negative 24. Then negative times negative will give us positive. So we have positive 3 times 6 will give us 18. So we go on, we have plus 75. Negative 48 plus 18 will give will give us negative 30. Negative 30 plus 75 will give us 45. So we've gotten the determinant. So that's determinant is 45. So I'll keep that now. So I go on, I'm going to form a matrix C of the cofactors of the element of A. That's what I will do next. So step 2 is to find or to form a matrix C of the cofactors of the element of A. So what I'm expected to have will be something like C matrix C of cofactors equals to A11, that's row 1 column 1, A12 row 1 column 2, A13 row 1 column 3, and it goes on like that. A21, A22, A23, then A31, A32, and A33. I want to form a matrix of cofactors, and a quick reminder that they will carry different sign. A11 will take plus, A12 will take minus. It will alternate just like that, minus, plus, minus, and this will be plus, minus, and plus. Let's start to form them now. So we have A11 will be equals to, A11 is positive, A11 is positive, so that will be positive. Then I close this place up, I close this column and this row up, I close it up. So I'm going to have 1 6 1 6 4 0. What I did was to close this up and this up. A11 is in that position. So when I find the determinant here, I'm going to have A11 to be positive 0 minus 24. So that's 1 times 0. 1 times 0 will give us 0, then 4 times 6 will give us 24. So A11 will definitely be negative 24. So I go on again. A12 here is negative. So negative, then I close up this, I close up this. So what I will have is 4 6 1 0. So I will put that in there, 4 6 1 0, by closing up this and this. So that is that. So when I find the determinant, I will have A12 to be negative 0 minus 6, and A12 will definitely be positive 6, or just 6. So I go on now. I have A13 is positive. It's positive. So A13, the cofactors, by closing this up and closing this up, I have 4 1 1 4. So that's what I will put in here, 4 1 1 4. So that will give us A13 to be positive 16 minus 1. That's 4 times 4 16, and 1 times 1 1. So A13 will definitely be 15. So same thing I do to get A21. A21 is negative, so negative. Then I close this row up. This A21 I mean, A21 is here, so I close this up, I close this row up, and I close this column up. So what I have is 3 5 4 0, 3 5 4 0. So when I do that, I'm going to have A21 equals to negative 0 minus 20. So A21 equals to 20. So I go again. I have A22 now will be positive positive, as we have here positive. So A 22, I will have to close this colon. This is A22, this is slotting here. So I close this up and I close this up. So that will be 2510. 2510. That will be A22 equals to positive 0 minus 5. I got that by multiplying 2 by 0 give me 0, then 1 by 5 give me 5. So we have A22 to be negative 5. So plus times minus 5, plus times minus 5 will give us minus 5. So we are almost there now. We are left with A23 and the last row. A23 equals to negative, A23 is negative, then I close this up. A23 is this slot, so I close this up, this colon up, and I close this row also up. So if I do that, I'm going to have 2 3 1 4. So I put that down, 2 3 1 4. So when I find the determinant, I will have minus 8 minus 3. 8 minus 3, that's 2 times 4 is 8, and 3 times 1, 8 to 3 will be negative 5. That's correct, negative 5. That's 8 minus 3 is 5, then the minus will come down. So we do the last column now. The last A31. A31 as we have here is positive, so that's this. So I'll close this up and I'll close this up to get the cofactors. So now I will have that to be positive 3 5 3 5 1 6, and that will give us positive 18 minus 5. That will give us A31 to be 13. That's positive 13. 3 times 6 is 18, 1 times 5 is 5. So we go on again. So to get A32 now, A32 is negative. So I'm closing this row up and this colon up. So that will give us 2 5 4 6. So if I do that, I'm going to have A32 to be negative 12 minus 20. So that will give us 12 minus 20 will give us negative 8. Then negative times negative 8 will give us A32 to be 8. That's positive 8. And the last one, A33 is positive. So I have positive, then I'm closing up this A33. So the cofactors here, I'm closing this up and I'll close this up. So I will have to work with 2 3 4 1 2 2 3 2 3 4 1. So when I do this, I'm going to have A33 to be positive 2, that's 2 times 1 minus 12. So that will give us A33 to be negative 10. So I haven't gotten the cofactors now. I'm going to form a matrix. I'm going to form a matrix with the values now. These are the values circled in blue because it's a 3 by 3 matrix. So I'm going to have about 9 elements. So I have a matrix of cofactors. to be equals to A11 is negative 24, A12 is 6, A13 is 15, A21 is 20, A22 is negative 5, A23 is negative 5 again, A31 is 13, A32 is 8, and A33 is negative 10. I have a matrix of cofactors now. I'm going to write that on a new page. The matrix of cofactors C equals to, so this is the matrix of cofactors of the given matrix A. So the third step to find the inverse of this square matrix is to write, if we write the transpose of metric C, we will have CT. That's how we write it, equals to, for the transpose of a matrix, the rows turns to column, and the columns also turn to row. So we have negative 24, then we have 20, we have 13, we have negative 6, we have 6, not negative 6, we have 6, so 6, negative 5, we have 8, we have 16, we have negative 5, and we have negative 10. So that is the transpose of the cofactors. So 2 more steps and we are done. So the adjoint, this matrix that has the transpose of the cofactors is also called the adjoint of matrix A. So what we have here is the transpose and is also the adjoint of the matrix. So now to find the inverse of the matrix, that's step 4 now. The inverse of matrix A is always written in this form, is equals to CT, that's the transpose, which is also the adjoint, over the determinant. So I will write this now. Recall that the determinant, as we did in the first step, is 45. That's what we got when we started. We got the determinant to be 45. So we'll bring that here now. We have the determinant to be 45. Then it means that A inverse will be equals to CT. CT is this matrix here, so divided by the determinant. So what happens is that each of the elements of the cofactors of the transpose, each of the elements divides the determinant, which is in this case 45. So as my final answer, since each of the elements cannot accurately or precisely divide 45, which is the determinant, another or a best way, a very good way of writing the answer is to factor out the determinant, which is 45 in this case. So it's going to be 1 over 45 into bracket. 1 over 45 will be out of the bracket as though it's a scalar multiplying the matrix. So 20, 13, 6, negative 5, 8, 16, negative 5, and negative 10. So this down here is the inverse of the square matrix given as A. Thank you for watching. Please, I would like you to subscribe and turn on your notification for my next tutorial problem. Thank you very much.